Okay, first off, couple of announcements. Even though on your packet it says the test is supposed to be tomorrow, remember I moved it to Wednesday. So today's your last lesson for this unit. Tomorrow we're going to review. Wednesday's your test. That also means journals are due on Wednesday. All right. With your donuts, just make sure the trash gets put in my trash can, and if you've got any like crumbs or anything on the desk, make sure you wipe them up before you leave. Also with your warm-ups, make sure that you are gluing them in your journal because those are your journal entries this time around, and that you are taking care of anything that we do not complete on them unless I state otherwise. Your vocab and your ICANN statements, that's still your responsibility. All right? So, like, for example, last week on Friday, I told y'all that check understanding for 6.4, that was your responsibility. You just didn't have to do the left side of the mathematic because we had that other activity that we did. All right? So, if you want full credit, make sure all that stuff is done when you turn in your journal. And remember, I post all that stuff in Canvas as well. So any of the stuff we did in class is still posted in Canvas for the journal. So if you miss something, it's there. All right. So everyone should have a calculator, and everyone should have already checked that it's in degree mode. All right. So again, like I said, if you're using the communal calculators, make sure you come in every day when we're doing trig and double check that it's in degree mode, because if it's not, your answers will get messed up. All right. So remember, you just hit the mode key, make sure degree is highlighted. If it's not, you scroll down to it and highlight it. For NumWorks, it should be in your settings. All right. So this warm-up was just a review on what we did on Friday of last week. So Friday of last week, we were mainly using trig ratios to solve for missing sides, as well as a little bit with missing angles using inverse trig. All right. So this warm-up kind of takes everything that we've learned as of yet in this unit and kind of just combines it together. So the stuff with similar triangles, the stuff with trig ratios, the stuff with inverse trig, the stuff with finding missing sides, it's all on this warm-up in some shape or form. So let's go through this together. So given that ABC is similar to UVW, they want us to find the hypotenuse of UVW. So what side length would that be of UVW? WU. So we're going to call this X. All right, so let's go with Reynolds. How'd you set this up to solve it? Uh-huh. Good. So you should have gotten 6x is equal to 180. And then what'd you get when you divide by 6? 30. Good. So in other words, since they were similar, remember that means the sides are proportional. So you could set up those proportions as long as you make sure the corresponding sides are, next to each other and stuff. Yes, sir.
Could you have also done 6 over 10 equals 8?
Oh, 100%. So if you did 6 over 10 is equal to 18 over x, that's also fine. All right. As long as you keep the corresponding sides and the same triangles around the same spot, whether that means the same triangle is in the same ratio or the corresponding sides are in the ratio, but then the same triangle is in the same spot in the fraction, that's fine as well. So how many times bigger is the hypotenuse on the short side? Anyone? It's 3 times bigger. All right. Now, we're going to find the sine of C and the sine of W. All right. So remember, these are our reference angles. So sine of C. So remember, that's opposite over hypotenuse, which we don't really need to label because that's the only sides that we're given for both triangles. So both of these are the opposite hypotenuse, opposite hypotenuse. So what is the ratio for sine of C? Let's go Reagan. So what's the ratio for sine of C? 6 over 18. Now, if we simplified 6 over 18, what would that give us? 1/3. All right. What about sine of W? Let's go with Nathan.
Sine of W equals 16 over 30.
Good. So how are these values related to what we did above? What's true? Right, they're both 1/3, so they're both the same ratio. Why? Because the triangles are similar. So because the triangles are similar, that's why when we take the sine of the same corresponding angles, we should get the same ratio. All right, because C and W are corresponding angles to each other. All right. Now, they then say in DEF, we're given sine of F is equal to 2/5. And it wants to know, what does this mean? All right. So it's saying sine of F is equal to 2/5. Now, we're assuming that that's a simplified ratio. Okay. So what does that mean about this number with sine of F? Anyone? First off, how do we find sine? Opposite over hypotenuse. So if we're assuming that that's a simplified ratio, what should that mean? Right. So what it means is that if we were to take opposite over hypotenuse of sine of F, we should get 2/5. Simplified. So let's look at them. All right. So here's angle F. That's our reference angle. So that means 14 would have to be what? What side? Opposite. What sides are our hypotenuse? FD. All right. Now, like Claire said, that also means that 14 should simplify down to 2. All right. So if we want to find DF, how do you think I would set it up? So we would have 14 over, let's say, X is equal to what? 2/5. Because your hypotenuse, whatever it is, it should simplify down to 5 after we do our calculation. So if I cross multiply, I should get 70 is equal to 2x. Divide both sides by 2. What's x equal to? 35. Which makes sense because 14 over 35, if you divide both by 7, you get 2/5. All right. Now, that's DF. How should I find FE? There's a couple of different ways you can go about it. You can definitely use Pythagorean theorem. So, I would suggest using Pythagorean theorem. You could have also done what? Couldn't we have also used trig? Yeah, you could have also used trig. But since we found two sides already, let's just use Pythagorean theorem. So, I'm going to do this off to the side. So I have 14 squared plus y squared is equal to 35 squared. 14 squared is 196 plus y squared is equal to, what's 35 squared? Guys, you got calculators in front of you. What's 35 squared? 1,500 what? Okay. Subtract 196 from both sides. What should I get? 1,021? 29? All right. Then take the square root of both sides. See if it's perfect square. If it's not, let's round to the nearest tenth. All right. So this would be... What the... Sorry, my brightness went down on me. So y should be approximately 32.1. Now, why is angle F congruent to angle C? And how do you know? So in other words, why would angle C, so the one up here, be congruent to this angle F? Could we test it? Or is it congruent to angle C? So what do you think? Is it going to be congruent to angle C? Angle F is going to be congruent to angle C. Yes or no? No. Why?
Short side.
We would have different ratios for sine. That's one major reason. So for example, we found sine of C to equal 1/3. Whereas the sine of F was equal to what when we simplified? 2/5. Thus, if we took the inverse sine of those, they would not equal the same thing. Because remember, the inverse sine is how you find the angles. All right? So if we took the inverse sine of those ratios, they would not equal the same thing, which means they are not the same angle measure. So in other words, they're not congruent. Now it says find the cosine of 23.6. All right. So in other words, you're just going to put this in your calculator and tell me what the value is. So let's say round to 2 decimal places. So put in your calculator cosine of 23.6. So what'd you get to 2 decimal places? It's what? 0.92. So it's 0.92. Now, what does that value represent? What is cosine typically? Adjacent over hypotenuse. So it represents adjacent over hypotenuse. So in reality, that would be about whatever we did for 32.1 over 35. So if we found 32.1 over 35, which should probably be around 0.92, but remember we did round the 32.1. All right, that would be about what it represents. All right, last part. Is triangle LKJ similar to DEF, and how do you know? So, probably the easiest way to figure this out is we need to find this third angle. Because remember, we can always prove that a triangle is similar by what postulate? Angle, angle. All right. Now, we have the 90-degree angle. We just need one other congruent angle. So we can find these two angles. So if you did 90 plus 23.6 and subtracted from 180, what would you get? It's what? Yeah, or 90, whatever. So you can subtract 23.6 from 90 as well. Good. What about here? If you did 35 minus 90, because you already have a 90-degree angle, so you know if you subtract that, you'll get 90 from 180. 55. So are they similar? Yes or no? No, because the angles are not congruent. So we can't use ratios, but we can still figure out JL. Why? So if I wanted to find JL, still using the angle that they gave us, how could I find it? I can do what? Couldn't I use the trig ratio? Yep. And it'll be sine of 35. So this is opposite hypotenuse. So if we do sine of 35 is equal to 20 over x. So we did this a lot last week. How do I find it? Right, you would switch the sine of 35 and the x. So this would be x is equal to 20 over sine of 35. And then just put that in your calculator. So what would that be approximately? 34.9. So again, as long as you got one reference angle and one side, you can find any other side. All right. And the reference angle cannot be the 90-degree angle. All right. So basically, your quick note here is just if you are given a triangle with a reference angle of theta and then three sides, so x, y, z. All right. You can find any missing side. So we can find any missing side using trig as long as we are given one side and a reference angle. All right, so as long as we're given one side and a reference angle, we would then just determine which trig ratio to use using SOHCAHTOA. So remember, SOHCAHTOA is your friend. And then you would just solve for whatever variable you're finding. So, for example, let's say I was trying to solve for x. All right. So, let's say that they only gave me y. So, this is what they gave me. So, x is my opposite hypotenuse and z is my adjacent. That means I could find sine of theta is equal to x over y, which means y sine of theta is equal to x. Now, on the opposite side, let's say they gave me z. All right. And I was trying to find And let's say I was trying to find, y. So still the same reference angles as adjacent over hypotenuse. So this would be cosine of theta is equal to z over y. So if I'm solving for y, that means y is equal to z over cosine of theta. So remember, depending on what you're trying to solve, so here we were solving for x, here we were solving for y, that depends on what you're actually, whether you're going to be multiplying the other number to your trig ratio or dividing that number by your trig ratio. All right, any questions on any of this? Yeah. Yeah, I think my eye kind of bled with my N a little bit. All right, the check understanding is for y'all to do on your own, because again, it's just review of what we've already done with it. All right, so now go ahead and take out your packet and keep out that extra problems packet, because we're going to be using that as well today. So take out your packet and go to page 17. Yeah. So page 17 of your packet, and make sure you keep out that extra packet of problems that you grabbed this morning, because we're going to be using that as well. All right, so our last lesson with trigonometry is we've already learned how to find missing angles when given the triangle. We already learned how to find missing sides when given the triangle. Now we're going to actually do some word problems with it. All right, so these problems specifically are called angles of elevation and depression. If anything like real world that you will probably use, especially if you go into, say, engineering or construction or anything like that, this is probably the most applicable. All right. So if you plan on being an engineer, you'll probably be doing this a lot. If you plan on going into construction, you'll probably be doing this a lot. All right. So now the ones in your packet, they already give you the picture, but we're also going to do some from that extra problems packet where you actually have to draw the picture, because on your test, I may not always give you the picture. So you got to understand what it's talking about. So we're going to start easy with some where they already gave you the picture, but then we're going to do some where they actually make you figure out the picture. All right, so we're going to be jumping around a little bit. All right, so a ladder will be unstable if it makes an angle with the ground greater than 60 degrees. A 12-foot long ladder is used to reach the window that is 10 feet above the ground, and it's asking, will it be unstable? So, in other words, it's saying that the angle with the ground. So we know our 90-degree angle would be the ground to the building. But which angle would be the angle that we're actually looking at? Would it be the angle here or the angle at the top? It would be the angle at the bottom. So this would be our reference angle here. So they're saying that angle, if it's greater than 60 degrees, will make the ladder unstable. All right. So how would I find that angle first off? So first off, let's label our triangles. So given the sides that I'm given, in reference to that angle theta, what's the 10? Opposite. What's the 12? Hypotenuse. So what trig ratio am I using? Sine. So let's just set it up that we already have it. So I have sine of theta is equal to what? 10 over 12. So how do I solve for theta? We talked about this last week. How can I undo the sine so I get the theta by itself? Inverse sine, good. Or sine -1, or arc sine, however you want to say it. That cancels. I get theta is equal to inverse sine of 10 over 12. And then you can just put that in your calculator. So go ahead and put that in your calculator. And let's round to the nearest degree. So theta would be approximately what? 56.14. So will it be unstable? No. Because 56.4 is less than 60. So again, these problems aren't necessarily hard if they give you the picture, because it's just like, every day what we normally do. All right, what we've been doing. It's when you don't have the picture that it gets a little complicated, because in my opinion, the hardest part is actually drawing the picture. Okay, so when they provide you with the picture, it's not hard. Now, let's try another one. So to determine the height of a tree, loggers will measure the angle of elevation to the top of the tree from a set distance from the base. So the logger's eyes are 5 feet above the ground, and the angle of elevation to the top of the tree is 38 degrees. Now, when it's standing 35 feet from the base, so what is the height of the tree to the nearest foot? So, first off, we got our reference angle. So, since we're finding the height of the tree, we know that part of the tree right here, so what would this little piece of the tree be? 5 feet. But now we need to find the other piece. So let's call that x. So in the end, we're going to take whatever answer we get, add 5 feet to it, and that'll be the height of the tree. So let's label what we got. So given my reference angle of 38, what's x in relation? It's the opposite. And then what is 35? Adjacent. So what trig ratio would I use? Tangent. So tangent of 38 is equal to what? X over 35, opposite over adjacent. How do I solve for x? Multiply both sides by 35. So 35 tangent of 38 is equal to x. All right, so x is approximately what to the nearest whole number? 27 feet. Now, that's not our answer, because now what do we have to do? Add 5. So the height of the tree is approximately 27 plus 5, which is equal to what? 33 feet. 32, yeah. Whoever's phone is that, turn it off. So, with problems like this, guys, be careful what it's asking you, because if you just found X and you told me that was the answer, it technically would have been wrong, because that's not the full height of the tree. Pretty easy, right? Like I said, it's easy when they give you the picture. So, pretty much, guys, with applying right triangle trig, you're just basically doing what we've been doing. If you're finding the missing side or missing angle measure, you're going to figure out the appropriate trig ratio based on what you're given. You use inverse trig for angle measures, and you use algebra for missing sides. All right. All right, here's another one. An isosceles triangle has legs of a length of 14 centimeters and a base of 10 centimeters. And it's an isosceles triangle. And wants to know, what is the measure of the vertex angle to the nearest degree? Now, this one does not have a picture, but we can draw it. So we have an isosceles triangle, which what's true about an isosceles triangle? Two sides are congruent. Now, those two congruent sides are known as the legs. So both of these will be 14 centimeters. The base, which is the non-congruent side, is equal to 10. And it wants to know what is the vertex angle. So the vertex angle is the non-congruent angle. So these two angles are congruent. The non-congruent angle is what we're trying to find. Now, you can't really use trig for an isosceles triangle, at least not with what we've learned currently. But can't we make a right triangle somewhere? How do you think? We could cut it down the center. All right, so let's say that we cut it right down the center to form a right triangle. So that means this would be 5 and this would be 5. So we know that these two angles have to be congruent, but we're trying to find the vertex angle. All right. So that means that these two little pieces would have to be congruent. So let's say that we're just trying to find one of them. So we'll call that theta. So how would I set this up? It would be the opposite over the hypotenuse. So what is the ratio I'm using? Sine. So sine of theta is equal to what? 5 over 14. How do I solve for theta? Take the inverse sine of both sides. So that means theta will equal inverse sine of 5 over 14. So round it to the nearest degree. So theta would be approximately what? It'd be what? 20.5, so let's say 21. Now, that's not our answer. Why? We have to multiply it by 2. So this is 21 degrees, meaning this angle is also 21 degrees, and we want to find the entirety of that angle. So we would have to take 21 times 2, and that would equal 42 degrees. So that's how big our vertex angle is. We're basing it off of this angle right here. So the one I marked with theta. Yeah, I probably shouldn't have marked these, but I was just showing that those two were the congruent angles. And we were finding the non-congruent one. So basically, when we're doing stuff like this, if I mark other angles, it's whatever one I mark as theta. That's what we're finding. All right. Now, angles of depression are a little bit different. All right. So the ones that we've seen so far are angles of elevation. So like this one was an angle of elevation. This one was an angle of elevation. Now we're looking at an angle of depression, which is a little bit different. All right. So the lighthouse in Cape Hatteras, North Carolina, is 200 feet above sea level. It spots a boat that is at an angle of depression of 28 degrees. What is the horizontal distance to the base of the lighthouse? So, in other words, if there was like a little dude up here, it's looking straight down at a sailboat. And the angle at which they're looking straight down is right here, 28 degrees. So if you think about it, the triangle that we're trying to find is here. All right, but the angle of depression would not be right here. All right, because if you think about it, with angles of elevation and depression, it's pretty much based off of sight line. So it's pretty much if you drew an eyeball, all right, all right, and that's a terrible eyeball, but you know what I mean. So if you drew an eye there, it's basically if you were looking down, where would the eye be? Because if I drew the eye right here, it would be looking at the water, not the sailboat. All right. That's how you can kind of know if you drew the angle correctly. So like here for the angle of elevation, if I made this a little eyeball, if I made this a little eyeball, all right, the dude's looking up at the tree. All right, so that's why that's where the angle is. It's where his eye line would be. Whereas here, he has to look down at the sailboat. Now, pretty easy to figure out though, because all you would do is just, draw another line, and then you have two congruent triangles. How do I know they're congruent? Well, what's true about this line here to the water? What do you think? They're parallel. All right. So they're typically parallel lines, which means that this angle right here is also what? 28 degrees. Why? They're not vertical angles. I don't know they're similar yet. I don't know they're congruent yet. But alternate interior angles, that's why. All right. So that means that if the lighthouse is 200 feet over here, that means that this is also 200 feet. Meaning, if we're trying to find how far away the boat is from the base of the lighthouse, X, that means this would also have to be X because they're congruent triangles. Because we essentially just formed a rectangle. All right. So it doesn't really matter how you set up because the trig ratio will be exactly the same. It does not matter which triangle you use. All right. So let's say I'm using the one with the angle that they actually gave me originally. So this one up here. Based off of my angle, what is my two sides? So 200 is what to the angle? It's the opposite. What's X? Adjacent. So what am I using? Tangent. So tangent of 28 is equal to what? 200 over X. How do I solve it? Switch the X and the tangent of 28. So X is equal to 200 over tangent of 28. So X is approximately what? So to the nearest whole number. $376 feet. So that's how far away the boat is from the lighthouse. Any questions so far, guys? All right. Try exercise 5 on your own. So I'll give you a hint with exercise 5. You're doing two different ratios. All right, thumbs up if you're ready. All right, one more minute. All right. Check your answer. So you had to do 2 trig ratios and then add your 2 answers together at the end. All right. So you should have found the tangent for when your angle was 24 and the tangent for when it was 38, because that's what you found your 2 sides. And then you just added them together. Any questions on exercise 5? All right, so we're not quite done with your packet yet, but I do want to try some where we're not given the picture. So go ahead and take out that separate packet of problems that I gave you guys. So don't put your packet up completely yet because we're not done with it, but grab that other packet. So, like I said, these problems are not necessarily hard. The hardest part is just making the picture. All right. So if they don't give you the picture, that's what makes it hard. All right. Because if you don't draw the picture correctly, then it messes up your problem. Okay. So we're going to practice some where you actually have to draw the picture. So let's look at number 1. So Kylie leads a 30-foot ladder against a wall so that it forms an angle of 74 degrees with the ground. And it wants to know, what is the horizontal distance between the base of the ladder and the bottom of the wall? All right. So let's just draw the scenario that's going on. So we have some wall right here. All right. The ground's right here. And then we have a ladder being leaned against that wall. They said the ladder is 30 feet. Now, where would these 74-degree angle be? It's where? It's with the ladder and the ground. So right here. Because the 90-degree angle would be the ground to the building. Because typically buildings are built perpendicular to the ground. So what are we trying to find? So guys, what's it asking us to find? Basically the length of the ground between the bottom of the ladder to the bottom of the wall. So that'll be right here. They could have also asked you for the length of the wall if that was the case, and you would have picked this side, but they didn't. So now that we got our picture drawn, let's set it up, or let's solve it. So based off of the sides that they gave me in reference to the angle that they gave me, what trig ratio do you think I'm using? Cosine, because this is my adjacent, this is my hypotenuse. So I have cosine of 74 is equal to x over 30. How do I solve? Multiply both sides by 30. That goes away. I get 30 cosine of 74 is equal to x. So put that in your calculator, round to the nearest hundredth, so 2 decimal places. So x is approximately what? 8.27 what? How do I get what? I probably read it. So 8.27 feet. So that would be my answer. All right, guys. So that was a fairly easy one. The ladder problems are usually the easiest. Okay? Any questions on that one? All right, let's look at number 2. So this one has a little bit more substance to it, and you'll see why. So from her eye, which stands 1.75 meters above the ground, Maisha measures the angle of elevation to the top of a prominent skyscraper to be 19 degrees. If she is standing at a horizontal distance of 337 meters from the base of the skyscraper, what is the height of the skyscraper? All right. So we start by just drawing the 2 pieces that we got. So we got some person, and then we got a skyscraper. So it's from eye level to the top of the skyscraper. So will I draw my hypotenuse starting down here or here? We'll draw it from her eye level. So we go from her eyes to the top of the skyscraper. She's at the base of it. So it says that, which stands, she's measuring the angle of elevation to the top of a prominent. So it's to the top, meaning she's standing at the base. Because it says right here, she is standing at a horizontal distance from the base. So she's standing on the ground. So if it's an angle of elevation, it's typically you're looking up at something. Depression is when you're looking down. Now, it says that she is standing 1.75 meters from the ground. That's how high her eyes are from the ground. So 1.75 meters from the ground. And she's standing 337 meters from the base of the skyscraper. So if that means she's 337 meters from the skyscraper, that means that this line right here is also what? 337 meters. So the right angle is right here. And it asks us what the height of this skyscraper is. So guys, that's what I mean by setting up the picture is the hardest part. You gotta read it carefully, all right? So some things to note. If it's saying angle of elevation, you're typically looking up at something, all right? So my angle of elevation, which is right here, because if you think about the little eyeball thing, your eye will be looking up at the top. And my angle of elevation is 19 degrees, because that's what they said it was. So, what's kind of my gameplay here? What do you think? Right, so we already got the first part of the skyscraper, which is just her eye height, which is this 1.75 meters. But now we need the other piece, which that's where our triangle comes in, or X. So like Elizabeth said, this is the opposite in relation to our angle of elevation. And the 337 is your what? Adjacent. So we're using what? Tangent. So we're going to do tangent of 19 is equal to X over 337. So if I multiply both sides by 337 tangent of 19 is equal to X. So if you round to the nearest hundredth, that's approximately what? 116 point what? 04? All right, so this is 116.04 meters. Now I'm not done because it asked me for the height of the skyscraper. So what do I need to do last? Add them together. So if you add them together, what do you get? 17.79 meters, which is the height of my skyscraper. All right, one more that we're going to do together, and then I'm going to have you guys try one on your own. And you'll see why I want to do this one together in a second. All right. So from an observation deck of a skyscraper. All right, so now the person's actually on the skyscraper. Brandon measures a 45-degree angle of depression to a ship in the harbor below. The observation deck is 1,140 feet high, and it wants to know what is the horizontal distance from the base of the skyscraper out to the ship. So let's just draw the two things that we're talking about. So we got some ship out in the harbor, all right, and we got ourselves a skyscraper. All right, and Brandon is standing on some observational deck on said skyscraper. Now, here's my question. It's an angle of depression. Okay. So if we're talking about from Brandon to the ship, all right, where would the angle be? Would it be here or would it be here? So in other words, would it be kind of below the observational deck or would it kind of be next to Brandon? Next to Brandon. Because if you think about it, if you're talking about his eye line, the eyeball will be right here, and it's looking directly at the ship. So this angle is your angle of depression, so 45 degrees. So guys, typically if you have an angle of depression problem, you're going to have it looking like that. All right, with a little dotted line at the top, and the triangle you're actually looking at is right here. All right, but remember, you can always make it a rectangle, and then you have two congruent triangles. Now, it says the observation deck is this high. And it wants to know what is the horizontal distance from the base of the skyscraper to the boat. Let's call that X. Now, remember, if this angle is 45 degrees, what's true about then what other angle is 45 degrees? The one next to the boat. All right, so two ways that you can go about this. You can either mark the congruent angle of the triangle that looks like it's an angle of elevation as well to solve it, or you could also say that this is 1140 on this side and that we're finding that angle or that side measure, all right, because they're congruent triangles. So whatever you're most comfortable with, that's how you can go about with angle depression. Because in my opinion, angle of depression is a bit harder than angle of elevation because a lot of times they mark the wrong angle. All right, so how would I set this up? Tangent of 45 is equal to what? Well, it's the same, but this would be opposite, this would be adjacent, this is opposite, this is still adjacent, regardless of which triangle you're doing, so it'd still be tangent. You're trying to find the distance from the boat to the skyscraper. Yeah, that's what we're finding. But if you were to mark it on the other side to make two triangles, they would be the same height. All right, so how do I solve? So switch the x and the tangent. Ugh, stop. No, it'll be a rectangle. Because we don't know for a fact that x is the same as 1140. And we're not actually squaring anything. So what I'm saying, guys, is that we can just make two different triangles. So guys, what this means is that with solving it, you can either solve this triangle, or if it's easier for you to see with an angle of elevation, you can solve this triangle. It doesn't matter. All right? Yeah. Exactly. Congruency, guys. So this is the same.
Well, we can say if the skyscraper fall, keep all the other people on the observation. Land on the boat.
So guys, listen. Shh. Like I said, angles of depression are a pain in the butt for this reason, okay? Now, it's because technically, if we were making the angle of depression, we're talking about this angle right here, all right? But we're talking about from the base of the boat to the skyscraper, which is here. So that's where that, parallel lines are make congruent angles, the alternate interior angles. We can put the 45 here as well and solve this triangle. But you could have also just realized, okay, so if we made a rectangle right here, that means if this side is x, this side also has to be x. If this side is 1140, this side also has to be 1140. And you can just solve that triangle. There's two different ways, all right? But you're still getting the same thing. We're still solving for x right here. Does that make more sense? All right, I'm just showing you guys two different ways you can go about it. But you're still going to be getting the same trig ratio. You're still going to be getting the same answer. All right, so to the nearest 10th, what's x approximately? It's actually 1140 point something?
No, it's just 1140.
Oh, well then it was a square. All right, that was completely coincidental. Which, yeah, okay, I can see that now.
So if
It's a 45, 45, 90 triangle, so, yeah, exactly. So I didn't catch that it was, okay, so guys, listen. So I didn't catch the fact that it was a 45, 45, 90 triangle. That's where I was getting confused with what y'all were saying. But that is another way you can do it. Because if it is a 45, 45, 90 triangle, then yes, special right triangles apply. But you can still solve a 45, 45, 90 with trig.
So
all right.
Is that one like the special triangle?
Yeah. So this technically would have been considered a special right. All right. So that's where the disconnect was between me and you guys. All right. That's where I was being like, what are y'all talking about? Because my brain's in trig, not special right triangle mode. Okay.
Would it still be approximately until you get the-
No, it's actually equal to it. So, yeah. Okay. Shh. Take a minute and try number 4. So try number 4 on your own. So draw the picture and solve it. All right, thumbs up if you're ready. Give you a couple more minutes. So be careful with this one. Make sure you double check what it's asking. All right, y'all ready? All right, check your answer. So the part that you had to be careful about was the fact that they said that her hands were 2.5 feet from the ground, meaning the triangle didn't start at her feet, it started at her hands. And then whatever you found to be X, you would have had to add 2.5 to it. Any questions on this setup? All right. Now, we did relatively easy ones today. We're going to do a little bit more complicated ones tomorrow. So tomorrow's lesson will be like really short. And then the rest of the time will be spent reviewing. So your homework for tonight in this packet, it's numbers 9, 10, 11, 9, 8, 10. So 8, 9, 10. So 8, 9, and 10, because those are just simple ones, but you just find the angles instead. And then in your packet, it's pages 19 through 20. And again, those are just easy ones. So pages 19 and 20, plus the 3 problems in your other packet. And I promise I will check homework tomorrow, hopefully, if I actually have time. All right. So again, 8 through 10 on your extra problems packet, and then pages 19 and 20 on your regular packet. So don't do 5 through 7 because those problems are significantly harder than what we did today, and I got to show you how to set those up. So y'all can go ahead and start packing up. Make sure your calculators are put up. If you have any trash from the donuts, make sure it makes its way to my trash can.